So first of all, thank you so much for coming after lunch and when it's such a beautiful day outside. And I know a lot of people are from the Northeast and this is great weather, and so I really appreciate your being here. So the purpose of the talk today is I just wanted to share materials with you on activities that I've used in the curriculum that will help students kind of manage their money, so kind of money strategies. And I think we have a unique opportunity in math that we can actually help them along and help educate them, and maybe some good spending habits and good savings habits. And the first thing I want to note is on your table you should have a yellow handout, and on the handout there's a website, and my PowerPoint presentation and all the activities I'm going to share with you today are going to be posted on this Miller sample website. And there's also a password. By the way, on the website there's the PowerPoint, all my activities, as well as there's videos, animated content. And please feel free to share these with your students. And it's password protected. The password is sign. And the reason the password is sign is because this is sign here, right? And if you have a sign, what do you also have to have? You better have a cosign also. So we have the black and white, the white and black, they're off by a phase shift, so I thought it was appropriate for the math geek here. So anyway, if I ever change the password, we know the next password is going to be cosine, so that'll help you. So anyway, let me give you the motivation and the reason that I thought that this talk was so important. I live in Daytona Beach, Florida, and our main industry in Daytona Beach is tourism. And so when the economy tanks and people have less disposable income, we really get hit very hard in Florida. And I think at one point we had almost 13% unemployment for a couple years in a row. So a lot of students came back to school, which was good for the school, but not so great for the economy and for Daytona Beach. So you can see here a couple of pictures. We've got spring break where all your students come down to see us for several weeks. And we also have the Daytona 500. We have 2 bike weeks during the year. So we have a lot of tourism, and as I said, the economy has been really hit us very hard in the last couple of years. So I think that anything we can do to help students kind of understand how money works, I think is really valuable to them. So the first thing I want to start out with today is I want to give you a quote that was given in Sports Illustrated. So this was back in 2009, and a little bit controversial figures here, but it mentions that within 2 years after retirement, 78% of former NFL players are in some kind of financial distress, and we know how much money they make. And then among NBA players, after 5 years, about 60% are in some kind of financial distress. And here's a partial list of some of the famous names of people who have actually filed bankruptcy. And again, the PowerPoint's on the website, so if you want to peruse this at your leisure and kind of go through the list of names, feel free to do so. And also notice if you end up seeing the athletes on Dancing with the Stars, it probably means they need money. So we had Dorothy Hamill and Warren Sapp were recent Dancing with the Stars contestants. So keep watching Dancing with the Stars if you want more information. So what I'm going to do is I'm going to take a little, I'm going to kind of follow a theme here. I'm going to kind of follow an athlete theme. And I watched a documentary that was done by ESPN. They have a series called 30 for 30, and they have some very fine documentary films. And so I want to show you a clip from one of the films. So let me play this first.
30 for 30.
Can you all hear this? You want me to put the volume up? Here.
It was extremely difficult to convince athletes to talk to us about this issue. Athletes have a lot of pride, they're very competitive, there's a lot of ego involved, so those players who have experienced financial difficulties aren't proud of that and aren't eager to necessarily share it with the world. And I give a lot of credit to all the athletes who participated and spoke with us.
I think I was surprised at how sympathetic I was to the athletes and to their experiences. I think that if I was their age and came into that kind of money, I'd have absolutely no idea what to do with it, how not to live so far beyond my means that I not only would wind up broke, but in debt.
My first contract, I think it was $6 million over 5 years.
7.6 million, 2.5 million a year. Number one all time. That's the biggest NFL contract in NFL history for a defensive player.
My first check was for like $500,000. $33.5 million for 7 years.
And then I went on a splurge.
That was like the coolest thing, to walk in the club and be like, yo, I'm here. I got me a bottle.
Louis the 13th, $5,000 a bottle in the club.
We drank so much Dom coming up as kids, we couldn't drink no more.
You looking over the whole club thinking you made it. Shallow as heck, but
my right-hand man standing at the door looking at me like, do you know what we just spent? And I'd be like, no.
He was spending $2 or $3 grand, easy.
You know, I would be laid out in the bed, knocked out, you know, $10,000 laying on the floor. I got another $5,000 hanging out my pocket. You might find another $7,500 in a coat.
You're talking about a mortgage here at the club.
$10,000 a week. Some nights, 15.
I had the money and I wanted to.
So I had the money and I wanted to. So the purpose of showing this clip from this film is I want to show my students that financial distress is not limited to people of lower income or even middle income, but really financial distress is more of a behavioral problem, and we can help fix that through education. So the first thing I like to do with my students the very first day of class is demonstrate that there's two types of ways to help them build wealth. And the first, of course, is with income. And what do we know that's very well correlated to income level is education level. So many of you have seen this slide before, but I bring this in the first day of every class I teach. And the bar graph on the right is demonstrating as we go up in education level, the median weekly income rises until we get to the PhD level, and apparently PhDs don't make as much as accountants and lawyers and doctors, but generally speaking, the more education we have, the more money we make. And then the bar graph on the left is representing unemployment rate. So as education goes up, unemployment rate goes down. So I think this is a really highly motivating slide for our students. And then what I also like to do is, rather than using contrived data for a lot of the examples we use in class, why not use real data? So here's an example I do in a pre-algebra class when it comes to talking about percent increase and percent decrease. So as a student increases his or her education level from an associate's degree to a bachelor's degree, the median income per week is $285, and that relates to a 37% increase in pay. And then to really make it, drive the point home, if we assume that they're working 52 weeks a year for 35 years, looks like it's $500,000. And of course, some of that is taken out in taxes, but we're also not accounting for the growth if they were to invest the money. So we're talking about a couple more years of education, we're talking a lot of money to them. So I'm hoping this makes things real for our students, and it's fun for me. So. Okay, so the next thing I want to point out is I also have a lot of my slides are snapshots taken from Excel. So if you're having trouble seeing in the back, feel free to move forward because I know it might be a little bit small. There's plenty of room up front. But most of my money activities all involve Excel because I feel like this also gives them a tangible skill when they go to an office setting. And they can, first of all, it gives them a tool that they can actually maybe learn how to enter formulas in Excel and actually make their own analyses on their own financial situations. So the first thing I do is I ask my students, if you were able to save $3 a day, now what's $3 a day? It's maybe a pack of cigarettes, it might be a couple beers at night, it might be that Starbucks coffee, except that's more like $4 something, right? So if they are able to scrounge together $3 a day, $21 a week, then at the end of a year they're going to have $1,095. So if they keep putting that $3 a day into a jar, at the end of the year they take their $1,095 and they can invest that money. They can maybe put it in a mutual fund if they, the money markets and so forth are not paying very much. So maybe they put that in a mutual fund with the intent that they're going to hold on to that money for a long time. Now notice in this spreadsheet I'm using a 6% interest rate, and of course that's dynamic. I can change that and it'll make the whole spreadsheet change, but they don't know that. They don't know if 6% is good or bad, so I like to use it for the effect, And notice what happens is that first year's money, the first $1,095 that they put in the jar, after a 30-year period, that's going to be, the interest will be compounded 29 times. Because remember, the first year they didn't get any interest, right? So this money, this number at the bottom, which is $5,900, is that $1,095 that's been compounded 29 times, with interest compounded 29 times at 6%. So now it's worth $5,900. So now let's say they continue the next year, the second year, they continue putting that $3 a day into the jar. At the end of the second year, they have another $1,095. So in the 30-year time period, or a window of 30 years, that second year's money is going to be compounded 28 times. Okay? And then the third year's money will be compounded 27 times, and so on. And so what the students will see then is the sum of the values in column C is representing the total sum of their principal and their interest. And so in column D, I've got the cumulative sum, and we can see that at the end of 30 years, they're going to have $86,000, which of course, after investment. So to all of us, we recognize this as an ordinary annuity. And the period, the compounding period is 1 year, and we're making payments at the end of the year, so it's an ordinary annuity versus an annuity due. So now I say for a college algebra class or pre-calc, depending on where we're teaching at the time, where we're teaching exponential functions and annuities, I have my students do this worksheet first. They do this Excel assignment first and they bring it to class. And so now when we go to derive the formula for an ordinary annuity, we now change, we put some symbols in instead of the numerical values. I'm now investing P dollars at the end of each year. And so in a 4-year period, at the first year's money is going to be compounded 3 years, the second year's money will be compounded twice, and so on. And what we see is we see a sequence of terms that are of the form P times 1 plus R to the T. And if we add up the value, the terms of that sequence, we get a finite geometric series, and we have a formula for that, which we do in college algebra and pre-calc, depending on what school we're at. So at this point, now we can massage the formula a little bit, and for A sub 1, the first term of the series, we can substitute P, and then for the interest rate, we substitute 1 plus R, and then we massage it a little bit because we say, typically, we might not necessarily compound yearly, but we want to compound monthly or n times a year. We make a clever substitution, and lo and behold, we get our formula for the ordinary annuity. But I think that by doing this problem numerically first, it just makes the derivation seem like it's not magic. It's a nice teaching tool. They've done some preliminary work to help them get familiarized with the problem before I present it in class. And then like the miracle that actually occurs is then they take their calculators out and they plug in the numbers, and we get the variety of answers, of course, at this point, because you know how the order of operations will go on the calculator. It's something that's complicated. But eventually, they work in groups and they eventually get the same answer, which is like too cool. Okay. So then they believe that the formula may actually work because they've seen it done numerically first. And so then we talk about it and say, well, realistically, we may not want to wait the entire year to invest our money. So what if we did it monthly? So I'm just going to say, what if we took that $1,095 and we divided it by 12? So that'd be $91.25 a month. So now we can use the formula for the ordinary annuity to get each of the values in column B here. And we can see how much money we're going to earn, or how much money we'll have at the end of each year, but with the interest compounded monthly. And what happens is, that's pretty darn cool, is at the end of the 30-year period, instead of having $86,000, we now have $91,000. So they have just by simply putting the money in more often, they can contribute to a mutual fund every month or every quarter or something like that. They can see physically how much more money they're going to get in that 30-year period and the value of compounding. So, but I think it's just a really nice way to have them massage this in Excel and have everything so consistent with the theoretical values. So then we say, well, what if we had a different kind of annuity? Instead of having an ordinary annuity, when we pay money into the system at the end of each compounding period, what if we paid the money at the beginning of the month instead? So this is called an annuity due. And what's really the only difference in terms of the final outcome between an ordinary annuity and an annuity due? It's 1 extra month, right? Because we're still making the same payments, but we're paying at the beginning of the month instead of at the end of the month. So if you'll notice on the formula, there's one extra factor. There's one factor at the end of 1 plus R over N. So there's one more interest payment, basically. And so what happens is we end up with an extra $500. So by compounding monthly and then, of course, changing from the beginning of the month from the end of the month to the beginning of the month, they make even more money. So I think this is sort of fun for them to see. We're doing that whole section in college algebra pre-calc. And in addition to this, I've also made a couple of animations, which you can go on to the website and find these animations. But let me just bring this one up real quick here. Okay. And it'll work.
This animation investigates the future value of an ordinary annuity.
I didn't mean for the
This
sound
is
to
an
come on,
annuity
sorry.
in which
I
money
can't
is
seem to-
invested at the end of regular compounding periods, n times per year.
Anyway.
Enter values for the principal, interest rate, time in years, and number of contributions per year. And for the interest rate, enter the value as a decimal form of the percent.
So the
For
point...
example, you might
sorry.
enter $200 in principal each month, that is 12 times per year, at an interest rate of 0.05
Okay, there we go.
for 30 years.
Okay. So the point here is that students can then go on, they can play with the numbers and see what's reasonable for them in their budget, you know, without having to go through and do all the calculations by hand. But it just gives them an opportunity to play a little bit. And of course, the formula is up here to remind them that this is not magic. So please feel free to share this with your students. The animation, again, is on the website. So, okay. So then the next scenario is sometimes students may get, you know, a bonus at the holidays. They may get an inheritance from a relative. Maybe they're in sales and they get, you know, a nice yearly bonus or something. So this spreadsheet is an activity that it allows them to compare simple interest versus compound interest. And again, I'm using a $10,000 lump sum, 6% interest for 30 years, 12 times, or compounded monthly. And notice that the difference is between the interest is $18,000 versus $50,000. So it really kind of gets their real eye-opener for them. And they see it again, they see all the numbers coming forth in the spreadsheet. And then it's also nice because at the bottom of the screen, they can compare the different compounding options. And this is something that I do in pre-algebra, believe it or not, because we do a section on compound interest versus simple interest. And this is something very easy for them to follow. And the pre-algebra students, to me, you know, get them started in Excel early. And so it's a simple spreadsheet, but for the pre-algebra students, it's really powerful. I've gotten really good feedback on this. So, okay, and also I'm just going to mention I have another animation here. I'm not going to play it, but the nice thing about this animation is that there's a text field where you can enter the value of n. And so what I usually do in class is I'll enter values of n like 1,000, 10,000, 100,000, a million, and you can watch the interest converging to what we would see if we were compounding continuously. So by continuing to increase the value of n, you can see it get closer and closer to that limiting value. So it's a nice one to use. Okay. So the next thing I like to do with my students is we talk about buying a car. So let's hear what the athletes have to say about buying their car. So.
First thing I bought for myself was a Cadillac Escalade.
I always wanted a Porsche, but didn't need the Porsche at the exact same time. I had the Escalade and a tricked out Denali.
So evidently they're still spending too much. So. By the way, the film, it's a great film, and I mentioned it to our athletic director at our college, and you can download it for $4.99 at iTunes. So he downloaded it, and they show it to some of the athletes at our school, some of the basketball players in particular. So we think they're all going to go to the NBA. So, okay. So in this activity, what I have my students do is we get into groups, and they go to there's a number of websites, but I have them go to a website called Edmunds.com. And at this website, they can enter a number of parameters about buying a new car. So what I chose is we're going to buy a new Honda Accord, it's 2013. I have a 1999 Honda Accord, it's 14 years old, still runs great, but if I wanted to replace my car, I want to know how much I would have to pay. So this is the example I'm going to use today. So the first thing is the website tells me in my area how much it's going to cost to take the car, drive the car off the lot. And with taxes and everything, it's going to be $26,000. So the next thing the website allows us to do is we can enter how much we're going to pay for the trade-in. So my car would be worth about $1,600, which means I'll be financing about $24,000. Okay. So then the website allows me to enter a down payment amount. I let my students pick what they think is reasonable for a down payment. So here we got a $2,000 down payment. So at the end of the day, we have to finance $22,500. Okay. So then, at the last stage of the website, you get to pick your options for the number of years you want to finance it. And the interest rate, when I looked it up, was about 4.5% in the area where I live. So our monthly payment would be $420 a month. Okay. So here's a summary of everything. Okay. And then we build a spreadsheet, and I do this again in a pre-algebra class. We build a spreadsheet, and we enter the parameters that we know. And the most important thing is at the end of the day, they're going to end up paying, or the end of the 5-year period, I should say, they're going to end up paying $2,670 in interest. But the bottom line is that most of our students, I'm sure, don't have $24,000 lying around. You know, I mean, the bottom line is that unfortunately, probably having to make payments is a reality to them. Now, they don't have to buy a new car. Maybe they buy a used car, but still, there's a pretty good chance that they're going to have to end up financing. So we all kind of agree with that. That's probably the scenario. So what we talk about in class then is what's the goal for them then? Right now, they may have to finance their car, but what's the goal long term? It's probably pretty obvious to us, but basically you want to keep the car longer than, you know, beyond the point where you're done. You want to pay off the car, keep it much longer than the period of time that you're financing it. So I say to my students, I said, what if you were able to pay, you pay off your car in 5 years, and what if you were able to keep the car for 10 years, so just double the amount of time. If you kept your car in good condition, you could do it for 10 years. The last 5 years, what you want to do is make payments to yourself. So you keep making the $420 payment, but you pay it to yourself. You maybe put it in a mutual fund, you put it in even a savings account, wherever you can. And so that to me sounds like an ordinary annuity, right? We're making fixed payments at regular intervals. So we go back to our ordinary annuity website, or to our spreadsheet, and so we're making for a 5-year period. At the end of 5 years, if you make that $420 payment to yourself for 5 years, you're going to end up with $28,000 at the end of that 5-year period, which is probably almost enough for a new car. And then if you're able to keep your car even longer, as I said, mine's 14 years old, at the end of that period of time, you may very well have enough to buy a new car and not have to finance. And so what's obvious to us, do you think that's going to be an obvious thing to the students? And unless they see the numbers, I think, in a spreadsheet, they're not going to believe you. They don't, or they may not want to make those $420 payments to themselves. But once they see the money growing, maybe they might be more inclined to do so. Okay. So then another place that we can kind of infuse discussion about money in the curriculum is we can talk about other costs of owning a car. So I have another worksheet for them, and of course we've already done our research and we know it's going to be a $420 monthly payment. So at the end of the 12 months each year, we're going to be paying about $5,000 toward our car. It was almost more than my mortgage payment many, many years ago. So, but then they have other costs that they forget to discuss. So we've got fuel costs and insurance, maintenance, repair, and so forth. So what we have to do is we have to project these. We have to make predictions. We're going to try to with sound mathematical reasoning, we're going to try to make a model that we can project what we think the fuel cost will be and so forth. So what I do is we make a couple of assumptions. We have a class discussion about this, and we make a couple of assumptions. The first thing is the car payment we know is going to stay the same. And I also kind of argue that the insurance will remain relatively the same. It may not go up or down by very much. And the reason is we know that insurance companies never lower their rates. Agreed? Right. But the value of the car is also going down with time. So the collision insurance is going to be less every year. Even though the insurance companies are going to creep their rates up, the value of the car is going down. So relatively speaking, the insurance shouldn't change that much. So we're going to make that assumption. And also the license and registration, if it goes up a little bit, it's not huge in terms of the cost of the other items. So we really have to try to forecast fuel costs, and we have to forecast maintenance and repair costs. So one way to look at fuel costs is we can look at historical data. This is actually nationwide. It's going to vary, of course, in our own areas. But these are the cost per gallon of regular unleaded gasoline since 1990. So we graph this, and we look at this, and we say, well, can we make a model for these data? And so depending on what class I'm in, we potentially maybe could fit an exponential model, but we talk about that might blow up pretty fast, so maybe that's not so great. But if we limited the data to maybe the last 13 years and just looked at the last 13 or 14 years, it looks relatively linear. In fact, the R value comes out to be 0.89, so it's a fairly strong correlation here. And so Excel will give us a nice linear model. And then what I get to do with my students is I say, interpret that model. It's roughly y equals 0.2x plus 1.27. I say, what does that model mean? What does that mean in the context of this problem? So it makes them actually now have to give a verbal representation of what does the slope mean. So the slope is increased in cost per gallon by 20 cents per year. and based on a base year in base year of 2000, with a price of $1.27 per gallon in the year 2000. So now we've made a model and we've actually interpreted it, and that's for fuel costs. Okay, so then we want to talk about repair costs, and I give the students a little bit of latitude here. They can discuss in their groups. And so I asked them, first of all, what do you think your repair cost is going to be for the first year, assuming that you have a new car? Okay, and they talk among themselves, and some people might be very mechanically inclined. They might do their own oil changes. And there's people like me that don't, you know. And so my students say, maybe they might come up with, say, $60 a year. I have no idea if this is too high or too low, but this is what a typical student paper might show. And so as a data point, that's for year one, it's going to be $60 as a data point. And I said, well, every year, you know, the car gets older, you're going to probably have to budget more for the maintenance and repair costs every year. So what's a good rate of increase that you might, you know, each year? And so then they talk about it among themselves, like what might the cost be for the second year and so on. And maybe they come up with something like a $50 increase per year. So they're going to budget an additional $50 every year for their maintenance and repair cost. So it seems like we have a point and a slope now. So it should be pretty simple to make a linear equation to predict what they might regard as their repair costs for their cars. Okay. So now that we have our two models of the things that are changing, we can go ahead and we can fill in a table. And the only thing that's a little bit tricky is they have to do a little bit of unit conversion. They have to do a little bit of massaging of the data for the yearly fuel cost, because everybody's going to have a car with a different fuel capacity. So they take the cost per gallon for a given year times the number of miles they drive per year, and then divide by the gas mileage they get for their vehicle. So they have to do a little bit of more calculations, and they fill this in. And so at the end of the year, you know, at the end of the assignment, they've got all these data values telling them how much they're spending each year on all these various parts of owning a car. And one of the things I think that's really astounding is I claim that in a lot of cases, people are going to spend more on their automobiles over their lifetime than they would their housing. Because think about it, if you buy a $150,000 house, you know, when you finish paying that house off, you've got the equity in the house, right? A car doesn't have equity, you know, it's not going to be worth anything after 10 years or 20 years. And you might have to buy multiple cars in your lifetime. So I actually claim you're going to spend more on your vehicles than you are in your house, probably. So it's kind of an eye-opening thought when you see how much money they're going to be spending on this. Let me pause for a minute here. Is this something that you guys might think you might want to infuse in your curriculum? Or I don't know if, you know, it's very concrete. I think my students like it, if that's any consolation. So, okay. So now we can go into the evil world of credit cards, what we've all been waiting for.
The more money you have, the more money you can borrow.
The black American Express card showed up in a James Bond briefcase.
Then when the credit cards came along, wow.
I wrote a check for $106,000 or $108,000 for 1 month. For 1 month.
You can spend until there's nothing left.
And I about threw up, and then I started to look back and backtrack and say, man, what did you get for all the stuff and the money you spent?
Okay. So do we think that credit card debt's a problem for a lot of our students? Probably. So probably a lot of us get, you know, 5 to 10 credit card applications a month in the mail, right? And this is usually what it looks like, and then you get your magnifying glass out. I had to zoom in like 1,000 times to get this to see it. So these are the terms of the agreement for the credit card. So I don't understand a word. I'm sure that our students are not getting any of it, right? So what I did do is I got offered a SkyMiles card, an American Express from Delta Airlines, and this was the terms of their agreement. So it's a 15.24% on charge on purchases, and then the penalty is 27%, and you know, cash advances and so forth. So these are the general terms, and I outlined this in a paper for my students. So then we go through a couple of different scenarios. The first thing we have to get the students to do is we want to have them understand how the credit card is calculating their average daily balance, because that's what they base their interest payments on. So here's a method that they use for average daily balance, and it might be a little bit small, so I'm just going to point out that in this example, we start on day one with $2,000 balance. And then on day 5, we make a $100 purchase. On day 17, we make a $70 purchase. And then on day 26, we make a $200 purchase. So that means that the first 4 days, we still have our initial balance of $2,000. Then beginning on day 5, we now have a $2,100 balance, and that goes until day 16. Then we add another $70. That takes us all the way to day 26, whereupon we make another $200 purchase. Okay, so if you think about it, we have a different number of days for each period, for each balance value. So 4 days, 12 days, 9 days, and 5 days. So doesn't this seem like a really, really good exercise for statistics in that first week when we're doing weighted means? Average daily balance. So you know those dumb contrived problems we do in all the statistics classes? If you do this, you really get their attention. So this is a great opportunity to infuse talking about weighted means and weighted averages for your statistics class. So we have our formula to compute the average, and what I'd like to do is I'd like to use Excel again, get them on the computer using the formula. And we see that our average daily balance for this month was $2,152. Okay, so that's the first thing that they get to do. Okay, so at that point, then we look and say, well, how do we compute the interest? And of course, every credit card is going to be a little bit different in how they compute the interest. And have you all noticed that they have all these acronyms? Like if it's raining on Tuesday, we do X, Y, or Z, and if there's an eclipse of the sun, you do A, B, and C. So part of the problem, I think, for students and for me is that having to know what all the acronyms mean. So we have the average daily balance, ADB, the APR, average percentage rate, and number of days in the billing cycle, and so forth. So we can use the first formula, or we can use the second formula. And I try to point out to my students that the second formula is you take your yearly balance and divide by 365. That gives you your daily periodic rate. So you take your yearly rate, divide it by your number of days, you get your daily periodic rate, and we multiply by the number of days in each period. So in this case, if we had $2,100 average daily balance, we'd be paying $26 in interest. So that's the second thing we do, is we talk about how the banks are going to compute the interest that they owe. Okay. So then we go through and we look at different scenarios in Excel. And this is one of the projects that they enjoy the most. So this time I'm going to start out with a little bit bigger number. We have a $5,000 balance. And I'm assuming that the student makes no further purchases to the credit card. We still have the 15% APR, which means the daily periodic rate is 0.04% per day. So the next thing you have to look at, the fine print, and you have to determine how the credit card computes their minimum payment for the month. So for this card, which is Delta SkyMiles card, it's going to be 2% of the balance or $25, whichever is greater. I think the greater of the two amounts. So for this first month, since we have a $5,000 balance, we take 2% of $5,000, and that's a $100 minimum payment for that month. If we go further down after many, 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 many months, eventually we're going to be below that threshold, and we'll be paying the $25 fixed rate rather than the percentage. So it's 2% of the balance or $25, whichever is greater. Okay, so what that means is with a $5,000 balance, the interest that the student's going to pay for that month is going to be the $5,000 times the daily periodic rate of 0.04% times 30 days in the billing cycle. So the student will be paying $62 in interest, and if the student paid the $100 minimum balance, that means that the student is only bringing down the balance by, $38? Okay, and then the cycle continues. So even though we paid $100, we're bringing the balance down by $38. So we keep going ad nauseum, and eventually we get to a point where the balance becomes negative. So we know that's going to be where we're done. So I could put an if statement in there, but it's just as easy to look and see where the negative number comes from in the spreadsheet. So you'll notice it took 264 months to do this. We do a gazinta, 12 gazintas, 264, or 22 years. So they made no other purchases with this scheme. It's going to take them 22 years to pay off the credit card. And they get to see the numbers themselves and they understand where they come from. It's very, very enlightening for the students. Okay. So then we go on and we say, well, you know what if in the first month you were able to pay off the $100 the first month? What if you were able to do that every month? You could come up and scrape together the $100 every single month rather than making the minimum payment. So let's see what happens. Where's the negative number? Looks like it's going to take 80 months. So from 264 months down to 80 months, now we're talking about less than 7 years. So we've cut it down by 2/3 of the time. The credit card companies don't want students to do this. And what's really interesting is when I was researching this talk, there was a study done by an independent consumer group. They took a group of 800 people. They split them into two groups of 400. They surveyed people randomly. One group of people, they gave them a credit card statement. I think the outstanding balance was a little over $5,000. And the one statement had no minimum payment noted on the statement. The other group of 400 people had a minimum payment required on the statement itself. Then they asked each person in both groups of 400 how much that they would put toward paying off the balance each month, how much they could afford if they wanted to pay off the balance. Well, some people just said, I'm going to pay the whole thing off because I don't want to pay interest. Those people had the funds to do it. But other people would just pay a part of it. And what was interesting is the researchers took the mean for each group, the 400, how much the first 400 people would put toward their monthly payment and how much the second group would put toward the monthly payment. And guess which group would say they'd pay off more? The group where there's no minimum payment on the statement, they would actually pay more. And the psychology, the inference from this article that I read was that people think that by paying the minimum payment, somehow they're meeting their obligation. They feel better about themselves. They're meeting their obligation because they're not penalized, because they don't want to pay the penalty. And they don't realize that, darn it, interest is a penalty. But somehow they feel better about themselves. So the psychology behind it, the banks don't want them. They want them to pay the minimum payment because they're going to get a lot more interest in the long run. Very, very sneaky. So then we move on and we say, well, what if we were to pay $200 a month? So we went from 22 years to 7.5 years. We're $200 a month. We're going to be done in under 3 years. And the banks don't want the students to know that. But when they do this assignment, they can see the importance. And of course, prior to 2003, this is what banks would do. So here we have almost a 25% interest rate, okay, on a $5,000 balance. So 2% of $5,000 is still $100. But the interest, almost 25%, is going to be $102. So notice the interest is higher than the minimum monthly payment, so the balance continues to grow. So they can never pay it off. Well, prior to 2003, banks did this, but legislation in 2003 required banks to set the minimum payment so that people could pay it off in a quote-unquote reasonable amount of time. But I'm not sure what reasonable is, because my Sky Miles card said, a 22-year was reasonable to them. But still, it's better than never going down at all. So anyway, that's lesson number 1 for our students. And then I have another slide and I say, what if you had your $5,000 balance and you decided you were not going to pay off anything? You're just going to ignore it, like pretend it would go away. Just put it in a drawer and hope it goes away. So according to the terms of my card, first thing that's going to happen is you're going to pay a $35 fee if you don't make your minimum monthly payment. Okay, and then of course you're still accumulating interest, but the bad news is if you miss 2 billing cycles in a row, 2 consecutive billing cycles, they now kick in the penalty interest rate. So they've gone from 15% interest to 27% interest, over 2% per month. So at the end of that 4-month period, they've now added an additional $502 in debt. And knowing that we started at $5,000, we're talking that they've just increased our debt by 10% in 4 months. So the moral of the story is don't ignore your credit card, but recognize that you've got to do something about it. So what would you tell your students? If you have multiple credit cards and you're in debt, what would you tell them to do? Like don't spend so much, but besides that. Right. Try to consolidate them on a card with lower interest. and then start paying off, try to pay off the higher interest card first and pay the minimum balance on everything you can, but then pay the higher interest rate card first, and then keep going from there, and pay more than the minimum payment. Okay. Okay. So let's learn about taxes.
You get that first check and you ask and you turn it on the backside and think there's another check back there somewhere because you're missing a lot of money.
The first time I got a check and I seen the chunk taken out of it, I went straight upstairs, and that's when I found out about taxes. That's when I found out everything.
Believe it or not, players don't realize that Uncle Sam's going to take half of that.
They think if they make $1 million, that they got $1 million. Make $1 million, what are you going to get, 550, 600 grand, 500 grand?
Uncle Sam is going to be your partner from this day forward.
An athlete's pretty much in the top tax bracket.
Athletes that makes a tremendous amount of money pays a tremendous amount of taxes as well.
Compare that to other wealthy people. Well, if you're a hedge fund manager or a private equity manager, you pay a lot less in taxes because, you know, you're taxed at what's called a capital gains rate, and so it's more like 15 or 16% instead of 30 plus.
We filed tax returns in 9 or 10 states.
Tennis players pay taxes in every country that they go in.
Okay. So the next thing, a nice activity for college algebra or pre-calc when we're talking about piecewise defined functions, of course, is to talk about the tax rate schedules. So here's I've kind of blown one of them up. I picked for single people. And one of the things I think is very interesting is a lot of people don't, even very well-educated people, don't necessarily realize that if you're in a tax bracket, let's say you're in the 25% tax bracket, it doesn't mean that you're paying 25% on all of your money. Because according to the tax rate schedule, you're paying 10% on the first $8,700 you earn. Then you're going to pay 15% on the next $27,000 that you make, and so on. So there's the percentage rates are staggered, and a lot of people don't realize that there's a difference between tax bracket versus effective tax rate. So to demonstrate this to my students, first thing I want to do is I want to see if they can interpret the table, because if they can't interpret this, then how are they going to interpret a piecewise defined function in college algebra? So the first thing I would do is I give them a different set of scenarios here. So if we had a single person making $62,000 a year, the first thing the students have to do is go down to the Schedule D, and they have to figure out how much tax they're going to pay. So they go through all the mathematics, and it turns out that they're going to end up paying about $11,500 in taxes. And they go through the other scenarios as well. And so then we look and say, well, what's the effective tax rate? How much tax did you really, what percent tax did you really pay? So notice they're in the 25% tax bracket, because that's their highest level of percent tax that they're paying on their highest money. But their actual tax rate is 18%. So if we divide the total tax by the total taxable income, it's 18%. Because again, it's another weighted average, another great activity for statistics class. And then if you look at all the other, I put the values in for the rest of the table. So this person making $205,000 is in the 33% tax bracket, but is actually paying 23% in taxes. So the next thing we do is we talk about the tax table, which is really typically where people go to look up their taxes. And the tax table would require $11,549, and that's because they're using the midpoint of a range, and we talk about midpoints, and if you actually notice that we're paying about $4 more in taxes is because $62,060 is less than $62,075, but they're using the midpoint when they use the tax table. We talk about that a little bit. And then finally, the last thing we can do in a college algebra class is we can take the data from the tax table, interpret it, and come up with a giant and really, really ugly piecewise defined function, but at least it's lending some credibility as to why this is an important skill we want to learn in college algebra. And then they can clean it up a little bit, make it look like a bunch of linear functions, clearing parentheses. And then finally, we can make the graph, and they can notice that the slope, of course, is the tax rate at each increment. So another nice application to use in a college algebra class. Okay. So we're kind of running a little bit thin on time here, so let me just quickly go through an activity about buying a home. The first thing I do, we put students in groups and we talk about the pros and cons of buying a home, because maybe it's not for everyone necessarily. you know, we want to make sure, I remember my parents, when I was going to buy my house, my parents said, don't take out a loan that's more than 2.5 times your income. You know, that was a threshold my parents recommended for me. So the first thing I do is we talk about the monthly mortgage payment, and we have the students go through a scenario where they compute this by hand. And then again, we take the variety of answers that they give us off the calculator. But eventually we get to the right place. And so we have some parameters here. We've got a $150,000 home. We make a 20% down payment of $30,000. So they're going to finance $120,000. So we go through and we put in some other parameters, the number of years in the loan and the interest rate. And eventually we end up with that the monthly payment's going to be $608. And then given that amount, the total amount we're going to pay for the mortgage is actually $218,000 because of the interest, and we've realized that we've ended up paying $98,000 in interest. The next thing we talk about is that your mortgage payment's not the only thing you're going to have to afford. So you have to pay property taxes, and again, I live in a very depressed, economically depressed part of the country. Our taxes on this might be $1,200 a year, so that's another $100 a month. With insurance, because of hurricanes, we got about $75 a month for insurance. And so we see that our monthly payment's going to go up to $783 for them. And they have to put this in escrow, and we talk about that as well. But the most important thing, I think, at this point is to build the amortization schedule for them in Excel. So we start with a $120,000 mortgage. And then we take for the first month, we're going to take our interest rate, divide it by 12, and multiply by the debt balance. And we find that the interest that's going to be paid from that monthly payment, the interest is going to be $450. Then that means if the mortgage itself was a $608 monthly payment and $450 goes toward interest, then that means that there's $150 that's going to principal, and we're only bringing down our debt by $158. So we go through that month after month, and of course we know that what's going to happen is that proportion is going to change. And eventually at the end of 360 months, we've got we've paid off everything, and we've paid $98,000 in interest. And so then we can look at this graphically, and we can say, okay, each month part of the money is going to principal, part of the money is going to interest. This is a great place to show them the algebra of functions. So we can take this as two functions which we add together. Principal plus interest is going to give us a constant function, the constant function, of course, being the monthly payment of $608. So it's a nice place to bring in addition of functions. It also shows them that they're still going to be paying more in interest than they are in principal up to about the midpoint of the loan. And then we can look at the total debt balance versus the principal, and it looks like 2/3 of the way through the process, they're going to owe more on the house than they have equity in the house. Okay, so it's not until about the 240th month, a little bit before that, that they're going to have more money invested than they are for their debt balance. So I believe we're kind of running out of time here. I have another part of this assignment where they pay off an extra $100 a month in principal, and they can see how that's going to change everything for them. Paying a lot less interest than pay it off sooner. And I had a couple other things. But I had one more activity that dealt with creating a monthly budget for a statistics class. And that's probably about all I had. So I know we have like one or 2 minutes for questions, so yes. Yeah. The question was, if a student goes off on his or her own and they research this on the internet, they might get a different monthly payment if they use one of those online calculators. And I mentioned to him there might be other costs involved, but we're talking about these are the major costs, because there's also like private mortgage insurance if you don't pay 20% down, that there might be other costs. But what I'm trying to do here is demonstrate how the interest and the principal work, you know, I'm not saying that this is going to be the formula they're going to use for real, but it's going to be a ballpark figure. And I'm also trying to demonstrate how the amortization works more than I am trying to get a really good fixed amount for their, you know, I'm not a banker, you know, I mean, so I think I'm trying to demonstrate the concept more than I am trying to find a really accurate figure for them. I don't know that would help you. Yeah, maybe they might use a slightly different algorithm to compute it. It hasn't come up, so honestly, I don't know how to answer that. I'm sorry. Sorry, yeah. So, other questions? Yes? I'm sorry, I couldn't hear you quite. So the question was, they have an aha moment, but whether or not does it really help them in real life? My feeling is I can't hurt them. You know, I mean, it's just, you know, what I'm also teaching them, I'm teaching them how to enter formulas in Excel. I'm teaching them how to graph in Excel. I'm teaching them how to analyze in Excel. So I feel like we're getting more skills than just the money part of it also. So I feel like it's, you know, they take what they can get from it. I mean, I'm presenting you can lead the horse to water but can't make him drink. So I feel like I'm giving them tools, and how they choose to use them down the road. I mean, I guess I can't really police that, but I think it'll help. It can't hurt. So another question, yes. I've always thought that if the high schools did this, and I actually think that every community college and even maybe university should offer a 1 credit hour course where they, you know, each week is a different scenario, maybe a different type of activity, and maybe we could prevent some of the, you know, bad behavior. And it's not that people are bad people, but they don't have the education to know how this works. I wish our school would have like a 1 credit hour course, maybe a free course even. I think it would help the community. Yeah. Right. Yeah, in my opinion, this goes way beyond consumer math, and we're talking about exponential functions and amortization. I mean, I think it's pretty sophisticated. Yeah. So, other questions? Yes. Okay. Yeah, they're always sending me. Oh, a good question. The Delta SkyMiles card has a $95 annual fee or something. Yeah. I didn't factor that in. Should have, yeah. Good point. Yeah. Didn't factor it in, so I have to update the activity. Other questions? Anything else? So, okay. Yes? Yeah. Oh, great question. Really good question. I started using Excel activities when I was teaching statistics. And I had a series of 12 activities that actually taught statistical discovery activities. And I have Word documents where it says step 1, you know, in cell A1 type this. Step 2, in cell A2 type this. So it goes through step by step by step. And I've used them so much that they're kind of like idiot proof at this point. And so actually they go on their own. I don't teach it in class. They go on their own, they learn it on their own. But they're allowed to get together. They can work with a partner to take the intimidation away. And so it's a Word document that tells them step 1, step 2, step 3, and it's pretty easy to follow. My students don't have any trouble. Molly's at my school, and the students don't have too much trouble. And again, these Word documents are on the website. They can create their own. A lot of times I'll use Excel in class, and I say, what do I type here? What do I, and they tell me what to type, because now they're getting better at Excel and entering formulas in Excel and graphing in Excel. So now I can use it after we've done 3 or 4 assignments in class. I can use Excel in class, and it's a great, analysis tool as well. But they expand. They can, work by analogy really well. And so I think, again, you're getting a tangible skill by learning Excel as well. Yeah. So if there's other questions, I want to be respectful of the next speaker, but if there's other questions, please let me know. So thanks so much. So, okay.